Hello everyone, and welcome to another remote sensing lecture video. And in this lecture video, what I want to do is I want to go back and I want to clarify some terms, and I want to wrap this all up in a nice little equation that I think will hopefully help clarify some of the stuff that we talk about in some later videos. So we left off talking about these basic interactions with the sun hitting an object, reflection, transmission, and absorption. What I want to do right now is I want to consolidate some of this in a couple of terms and then wrap those terms up in an equation. So what I want to do first of all is I want to draw out our system again. I'm going to use white this time so we can use the colors to represent something different. So we have the sun, we have our leaf, right? Put some veins on this leaf. It'll look a little bit nicer. Okay, so what we're going to talk about in future videos is the idea that there's actually a sensor over here that's doing stuff, that's actually sensing things. But what I want to do right now is I want to coalesce everything into some terms. So the first thing I want to do is I want to talk about when we talked about the electromagnetic radiation coming out, right? The energy that's coming down and hitting the leaf right here, right? This incoming radiation, the term we often use is called irradiance, right? Irradiance, 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 and you'll often see it denoted as a capital I, and then just to be consistent with our terms here, irradiance is the incoming radiation. Right? Irradiance is incoming radiation. So irradiance, incoming radiation. So in our previous video, we said that there were three things that could happen. The first thing that could happen is that the energy passes through, and hopefully these colors don't confuse you. Please keep track when I'm using colors here. Blue in this case is going to be going through the leaf. So blue is going to be transmitted, right? We talked about transmission, right? Transmission. And this is going to be, you'll see it denoted with a T for transmission. And transmission, again, is going out. Or passing through, going through. Right, this is just a really quick recap. We said that some energy could be stored in the leaf, right, or in the object, and this energy here is called absorbed, right? And we denote that with a big A. And then we said the last thing that could happen is that it could actually be bounced off, and it could go like that. And we said that this was reflected. Reflection. We denote that with a big R. So just to clarify, absorbed is retained in, is kept in. And reflected is bounced off. All right, so these are the three things that we talked about before. The term that I've incorporated here is this irradiance, which is incoming radiation. And then in some subsequent videos, we're going to talk about radiance, which is the amount going off. But what I want to do right now is capitalize on these terms we have, I, R, A, and T. And what I want to do is I just want to do something that hopefully makes some logical sense here. And I want to put these things into an equation. And we're going to start with irradiance. We're going to start with our I here. Then we're going to have our reflection. Our absorption. And then finally, our transmission. I like to think of it as IRAT, just because it's a mnemonic device I find helpful. But the way these things are related, and hopefully this makes sense, right? So if the irradiance is the amount of coming in, right, the amount coming in has to equal the amount that's bounced off, plus the amount that's kept in, plus the amount that goes through, right? Hopefully it makes intuitive sense that the system is equal, so everything happening here has to equal what came in. So I equals RAT, IRAT. So what I want to do now is I want to take just a second here and I want to talk about what drives this relationship here. All right, so let's formalize that for a second. What drives the interaction, right? What decides whether the radiation, right, whether this irradiance is going to be primarily reflected, primarily absorbed, or primarily transmitted? All right, what determines whether or not it's going to be reflected, transmitted, or absorbed? And there's really three things, right? The first thing, the number one factor, is going to be the wavelength. Of the radiation. Right. And hopefully this makes logical sense, right? Because we can imagine that there's all different kinds of wavelengths coming from the sun, right? There's red, there's green, there's yellow, there's ultraviolet, there's near infrared, there's gamma, there's X-ray, right? All these different types of radiation are coming from the sun. And all these different types of radiation are hitting the Earth. But what they do when they hit the object, right? It depends. It depends on the wavelength. That's why when you see a leaf, right, the leaf appears green because our eyes can only see an invisible spectrum, and the red and blue wavelengths are primarily being absorbed by chlorophyll, right? So in this case, the wavelength when it hits the leaf would dictate that in the green region it would be reflected versus in the green or in the blue and red it would be absorbed. So that's the first thing that drives the interaction, is the wavelength of the radiation in question. The second thing, right, the second thing that drives the interaction are the properties of the matter, right? The properties of the object. Right, and these properties could be things like size, shape, and chemical composition. Right, size, shape, and chemical composition are three of the big ones. Right, and again, going back to that leaf example, right, leaves have chemicals inside of them that make them more likely to absorb red and blue and less likely to absorb green. Right. So the wavelength matters, the properties of the object matter. And then the third thing that drives these interactions is actually the angle the angle, wow, my brain right now, the angle of interaction. All right, and we're not going to spend a whole lot of time talking about angles in this course because it's a little bit outside the scope. But the key point here is that the sun is constantly moving, right, and the satellite is constantly moving. And as the angle of the sun changes, it actually changes the interactions. And this is one of the reasons why when the sun is overhead in the sky and you look up, the sky appears bluer. But when the sun starts to set, that's why it appears redder, because that angle of interaction is actually changing the way that the light is interacting with the atmosphere. So it changes from a blue to more of a red. So hopefully that makes sense. But the idea here is that the three things that drive whether or not it's going to be reflected, transmitted, or absorbed are the wavelength in question, the properties of the object, and then the angle of that interaction. So again, hopefully that makes sense. If you have any questions, I strongly encourage you to pause the video, rewatch the parts you're confused about, and as always, please reach out. Thank you.